In this video, your objectives are to find the area of a sector given the radius and essential angle. Also, you are going to be finding angle or radius given the area sector or the angle or the radius. You have these two equations, one for degrees and one for radians, depending on your angles. Notice how the pi r squared here and here, that's just the area of a whole circle. And the fraction in front tells you how much of the circle you're talking about. So the area formula is within this area of a sector. A stands for the central angle. R should be radius. And pi is just your constant ratio of your circumference to your radius. And it's approximately 3.1415 ... goes on forever. So finding the area of sector, essentially you're finding the area of a slice of pie out of a whole pie. So this first one, find the area of this sector. We have a circle here, the radius of 6. Okay. Your central angle is 72 degrees. So you're going to use the formula for degrees, A over 360 times pi r squared. So you need, in order to find the area of a sector, the central angle and the radius, which both of these we have. So plug in 72 degrees in for A, your central angle, times pi times the radius squared, so that's going to be 6 squared. And approximately, you can just type this in all at once, 72 divided by 360 times pi times 6 squared. And it's going to give you 22.62 approximately units, square units. So if it's feet in the radius, it's square feet, meters, square meters for area. Unlike arc length, which is one-dimensional distance, this is area, this is 2 dimensions, so it's a square unit. Number 2 says find the area of a sector with a radius of 9 centimeters and a central angle of 1.5 radians. So find the area of the sector. So this is asking for area of a sector given the radians. So we're going to use the radians formula. So instead of 360, there's a 2 pi in the denominator. They do give us the central angle, 1.5 radians. So that goes in for A, times pi. They do give us R as well. It's 9 centimeters. So plug in 9. And you can actually type this in as well, 1.5 divided by... And remember, when you put 2 pi underneath the fraction, you need to put the 2 pi in parentheses. When you're calculating. So times pi times 9 squared. So it's actually 60.75 exactly square centimeters. In this problem, it tells you a sector of a circle whose central angle is 150 degrees has an area of 605 over 12 pi. Find the radius. So we're asked to find R here, and we're going to use the degrees formula because they give us an angle in degrees. Now, out of our 3 variables, they give us the area of the sector. They give us the central angle. We don't know the radius, though. So we're going to plug in our known values and solve for our unknown. So it's going to be 605 over 12 times pi equals, and A is going to be 150 over 360 times pi r squared. And we're going to employ the use of reciprocals again to solve for a missing value. Rewrite it underneath here. It's a little easier to see. So I want to get R by itself, for R squared first. So first thing I'm going to do is multiply both sides by the reciprocal of the numbers I want to get rid of. So 150 over 360, 150 is in the numerator, it's going to be in the denominator now. Same with pi, also in the numerator, going to be in the denominator. 360, it's in the denominator, now it's going to be in the numerator. And what this does is, it all cancels out to 1, which is why we use it, because it isolates r squared. And over here, you're going to have the pi's cancel, and then you can multiply 360 times 605, divide that by parentheses 150 times 12, and you get 121 when you simplify that out. And to get rid of the power of 2, you're going to square root like we did before in the area of circles, and it's going to be actually exactly equal to 11, and it's just regular units. So the two objectives, we met them both. We found the area of a sector given the angle and the radius. We also solved other problems where they give you area of a sector and an angle and actually solve for the radius. We did not do a problem where they gave you a radius and an area of a sector and asked you to solve for an angle, but it goes much like the previous problem here.